Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Find the derivative of the following: x equal to a times cos t plus t sine t and y equal to a times sine t minus t cos t, right? So we have a parametric equation in place where x is represented in terms of the parameter t and so is y, and we've been asked to find dy by dx. So our step one towards solving this problem would be to write down the formula for dy by dx. And in these problems, our dy by dx is nothing but dy by dt divided by dx by dt, right? So we have our y in terms of t, we have our x in terms of t. So I don't think we have a challenge here in terms of figuring out what is our dy by dx. So let's write down what is our y first. My y equals a times sine t minus t cos t, right? So I'll go to the next step because looks like we have an application of sum rule and a product rule here. So my dy by dt, I retain a as it is. I go inside and then my d by dt of sine t is nothing but cos t. And then my d by dt of t cos t is what I need to find out, right? So there comes the application of my product rule, right? So let me write down d by dt of t cos t, right? So we have an application of a sum rule, we have an application of a product rule, right? So when I write this and I retain the a as it is, my cos t remains as it is. And then when I apply my product rule, which is d by dt of t cos t, I first do the differentiation of cos t. I retain my first function. So when I do that, I get a minus sine t. And why is that? D by dt of cos t is nothing but a minus sine t. And then in my next step, I retain the second function and then I do a d by dt of the first function. My d by dt of t is nothing but 1, right? So this is what I have, right? So let me go to the next step to write down what is my dy by dt. So my dy by dt is equal to a times cos of t minus of minus t sine t, which means it becomes a plus t sine t. And then I have a minus of cos t, right? Now you see that my cos t gets cancelled and I'm left with at sine t, right? So that's my dy by dt. Now let's go to the next step and evaluate what is our dx by dt, right? So I'm going to pick up my x going back to the problem. My x is a times cos t plus t sine t. Again, we have an application of a sum rule and a product rule here. So my x equals the expression that you have on your screen right now. And then I do my dx by dt equals a times step 1 application of sum rule. So d by dt of cos t is minus sine t. And then I have product rule coming in place here, which is d by dt of t sine t, right? So it's a product of two functions which are t and sine t, right? So now I know what to do, right? So my first minus sine t remains as it is. And then I have a d by dt of t sine t. So what do? I retain the first function as it is. I differentiate the second function with respect to t. I get a cos t. And then my step 2 within the product rule is I do a d by dt of the first function, which is t, which is nothing but a 1. And then I retain the second function as it is, right? So there we have minus sine t plus t cos t plus sine t, right? So our sine t cancels out and then I'm left with dx by dt equals at cos of t, right? So I have now with me my dx by dt. Let me highlight it in a color, say green. And then I have my dy by dt. Let me use a different color, say yellow. And then I go to my original dy by dx formula in terms of dy by dt and dx by dt, and then I substitute them with what I just now calculated, right? So this is the yellow expression, which is at sine t, which is my dy by dt. And then I'm going to go and put my dx by dt, which is my green expression, which is at cos t. So I go up and then I substitute at cos t, right? So there I have at sine t divided by at cos t, right? What happens to my at? It cancels out, and then I'm left with a sine t by cos t, which is nothing but a tan t, right? So, okay, being a parametric equation, okay to leave our final answer in terms of t, right? You don't have to necessarily eliminate the parameter in these problems unless you've been asked to do so. So my dy by dt, let me put it in the beautiful pink color, is a tan t. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.